Hello students, we see the next practical from the same group, that is general physics. As I sent you the first video regarding this practical also, and now it is second. Actual what do you perform here, and by using the given observations and observation table, you have to plot the graph and perform the further calculations and take out the final result. Now we move towards title of the experiment, Young's modulus by Koenig's method. Aim to determine Young's modulus of material of bar by Koenig's method. For this apparatus, mirrors, this one and this is second, two knife edges, these are the two knife edges 1 and 2, then telescope in order to focus the scale, lamp for viewing the clear readings on the scale, hanger for applying the slotted weights to the bar, meter scale, vernier caliper, micrometer screw gauge, and the mounting stands, for one for scale and one for the telescope. Now this is the ray diagram. We see it in detail. It is the scale, vertical scale. It is the horizontal scale of which we can determine the Young's modulus as the elastic constant. To the horizontal scale, we have to mount these two mirrors M1 and M2. Now what do you do further? We have to see this remote scale into this mirror, vertical scale into this mirror with the naked eye, and then we have to see this adjust this mirror in the first mirror along with this scale. And the third step is we have to focus the scale into the mirror through this telescope, and those changes after applying the loads in the range of 50 gram, we have to record or note the change in the scale reading. In two steps, one loading and another while unloading in the same steps. The first ray comes from this vertical scale to mirror M2, then reflected ray from mirror M2 to M1, and the final ray is focused in this telescope for the reading. It is the experimental adjustment for the calculation of Young's modulus Y by Koenig's method. This experiment is devised by the scientist Koenig, hence its name as Koenig's method. With this formula, y equal to 3/4 GL square upon BD cube into M upon 5, we have to calculate this formula y. Now x upon 2 times 2d plus a into 5. Now L is the distance between two knife edges. It will be equal to nearly about 40 centimeter. A is the distance between two mirrors. It should be equal to 80 centimeter. M is the mass attached to the center of the bar in the range of 50 grams. B, breadth of the bar, which has to be determined with the help of vernier caliper. D, depth of the bar should be measured with the help of micrometer screw gauge. And X is the depression of the bar. Now we are giving here the values, that is L equal to 40 centimeter, distance between two knife edges, distance between two mirrors A equal to 80 centimeter, distance between the scale and mirror D equal to 91.5 centimeter, or it may be equal to 92. Then least count of vernier caliper of 0.01 centimeter, least count of micrometer screw gauge is 0.001 centimeter, breadth of the bar B equal to 2.75 centimeter, and thickness of the bar D is equal to 0.561 centimeter. These are the observations we have to use for the calculation here. Now we have to complete the observation table. Mass attached m gram, scale reading while loading and unloading. Obviously its mean should be taken. Then we have to calculate the depression. Then angle of flexure we have to calculate by the formula x equal to 2x upon 2 times 2d plus a. This mass attached we have to starting here from 0, 0, 50, 100 and so on in the range of 50. When there is a zero load, we have to take the scale reading in the crosswire, telescope crosswire. We have to adjust the horizontal crosswire to the zero scale and take out the reading. Then to that hanger we have to add 50 gram load and take this reading. Then again 50 and so on, and we have to take sequentially these readings, that is loading. This column is completed. While you are performing towards the unloading, as we know that the last weight, this reading kept as it is. Then we have to remove one load from that, then take the reading, again remove one load and so on up to 0. Then we have to, these two readings, loading and unloading, are nearly equal and therefore we have to take its meaning. Now we have to calculate the depression x. Now what is this? We have to take the successive difference between these two readings, that is between 50 to 0, it is here, then 100 to 50, then 150 minus 100, 200 minus 150 and so on. That is ultimately there is a difference between successive difference, that is the we have to determine here the depression for each 50 gram load, means it is 50, 100, 150 and so on. Now once you know this x, this d is known, a is known in the observation, and by using this formula we have to calculate the angle of flexure equal to this. And then the first column is m, last column is phi, therefore we have to take their ratio here m upon phi and it comes out to be this. Now we have to plot, by taking the mean we have to calculate y by calculation, result by calculation, and by plotting the graph of m versus phi we have to plot the graph m on y-axis and phi on x-axis, and then we take the slope which can be used in the formula and make the result for y. Here after calculation it will like this, by it's the result by mean and it's the result by graph, y equal to 0.68 10 to 11 dynes per square centimeter and y equal to 0.71 10 to 11 dynes per square centimeter. These are the two results, one by calculation, another by graph. Since it is the elastic constant, it should be multiplied by 10 raised to 11 and the unit is CGS unit is dynes per square centimeter. We are using here the material of the bar as a wooden bar, wood, and therefore it is comes out to be nearly equal to 1 into 10 to 11 experimental. We have the final results in this way.